So, hello everyone, good morning, all of you. I think all are well, right? So, see here now, just I have completed yesterday electric charge and field means first lecture. Now, I want to discuss here second lecture, and I have written one question. Find the ratio of electrostatic to gravitational force for two electrons placed at some distance apart in air. Charge on electron it has given 1.6 into 10 power minus 19 coulomb, and okay, mass of electron 9.8 10 power minus 31 kg, and k value 9 into 10 power 9 Newton per meter square per coulomb square, and g value is given. Okay, just simply I want to how can we solve this question. See, we have two charges. First is e electron, and second is also electron. Both are electrons present. Check here, right? Electrons, two electrons present, two electrons present. Some distance, okay, assume this distance is r. Assume this distance is r. Okay, very good. Now tell me what is mass of electron? 9 into 9.1 into 10 power minus 31 kg. And what is mass of electron here? 9.1 into 10 power minus 31 kg. Very good. Next, see here. What is charge of electron? Minus 1.6 10 power minus 19 coulomb. What is charge of electron? Minus 1.6 10 power minus 19 coulomb. Very good. Tell me, if both means both this point, both object has, not I am telling just this is point object, right? Okay, both point object has mass present. It means that here gravitational force will exist, and both have charges also. So between two charges electrostatic force will exist. So mass, due to mass gravitational force exists, and due to charge electrostatic force will exist, right? So just simply I want to write here what is gravitational force. Tell me. This will be G m1 m2 by r square, right? And what is the electrostatic force? K q1 q2, because both are same. Check here also, q value is minus 1.6 10 minus 90. Here also same. Okay, r square. Now I want a ratio of both. Check Fe by Fg, this by this. Okay, so Fe by Fg equals to K Q1 Q2 by R square by G M1 M2 by R square. Check. Now see, R square cancel out. Okay, this will be K into Q upon G M into M. Check. Understood? Simply, what is K value? 9 into 10 power 9. What is Q value? Check Q value. Now you can ask, sir, why is here we will use the Q value minus 1, but no. Just I want mod, right? So put Q value is 1.6 10 power minus 19 coulomb, right? So 1.6 10 power minus 19 coulomb into 1.6 10 power minus 19 coulomb upon G value. Check. G value will be 6.67 into 10 power minus 11. And what is mass value? Check here. Mass value is 9.1 into 10 power minus 31 into this value also minus 31. If you will solve here, so approximately you will get Fe by Fg approximately 10 power 42. I think this option correct, right? So next, right, another question. A charge K is divided into two parts. A charge Q is divided into two parts such that when two parts are kept at some separation, the Fe between them is maximum. So find charge on each part. See. Okay, see. A charge Q is divided into two parts. Understood? So we have one charge Q. I want to divide between two parts. So simply you can write Q1 minus Q2, and I am asking what is Q1 plus Q2 value? This will be nothing but Q. But see here, how many variables? Two variables. You know, in any calculation, we have to minimize the variables, right? Here two variables present. Okay, you can solve, but here two variables present, and you have another only one equation. Just I want to write here this. Let us first charge is x and second charge is q minus x. Tell me the sum of this x and q minus x. You will get q. So I think this will be better. This will be means actually I am taking a lengthy problem, right? X and q minus x. Now see, we have one charge x, correct? And we have another charge q minus x. Very good. See here. So now the distance between both, it has given some separation. Okay, let us assume r. So it is given such that when these two parts are kept at some separation, the Fe between them is maximum. Okay, so if I want to put that charges, so I will get here Fe maximum. Correct. See, you know, in mathematics, for maximum minima, first we have to differentiate with respect to variable. See, simply I want to tell me what is electricity first. Tell me electricity force. This will be K Q1, Q2 by R square. What is Q1? This will be X. And what is Q2? Q minus X upon R square. If you will solve, K into X into Q minus X, right? Otherwise you can write this thing, Qx minus X square upon R square equals to Fe, right? Next thing. Tell me what is variable. You can tell sir variable is R also and X also. But see here, I want to tell one thing here. Here I want to focus on X because I want to calculate X. So it means that here it is partial differential equation. So here I want to differentiate with respect to X because my focus to calculating X only, right? So in case of maximum, just I want to write dou F by dou X. Why not dou R? Because just I want to calculate X value. I will assume here X is variable. Understood? So this will be differentiation of K Qx minus X square upon dr square upon dx, right? Check here. Check. Is correct. Now see, r square and k constant, take common. K upon r square, take common. Now differentiation of Qx minus X square by dx, check. Now here this is a by b ratio. You know, suppose differentiation of a by b by dx, this will be b square into b dA by dx minus a dB by, you know, this thing. Similarly here also, actually here only Qx minus X square numerator present. So simply we can write here K by R square, and this will be differentiation of Qx by differentiation of minus differentiation of X square by dx, right? Acha. And I told first calculate means first derive differential equation means, and after that put equal to 0. So put equal to 0 like that. So this will go this side 0. Okay. Okay. And tell me what is value here. This will be q minus 2x equal to 0. So shift this to x right side, left side. This will be 2x equals to q. So x equals to q by 2. It means x equals to q by 2, right? This will be q by 2. And what about this? This is also q minus q by 2. This will be q by 2. So both are q by 2, q by 2. Okay. Both are q by 2, q by 2. See, uh, simply I want to tell one thing. Limitation of Coulomb's law. Limitation of Coulomb's law. See, suppose we have this Q1 charge, Q2 charge, assume point charge. So in case of point charge, Coulomb's law applicable, right? But suppose this is extended charge, means rigid body. So in this case, suppose both are present, means near to each other, means distance is less. In that case, we cannot use directly Coulomb's law, means Q1, Q2 we have, because Q1, Q2 they are point charge, right? Okay, if I want to put that reciprocity at infinite or means a very large distance, okay, using I can assume, okay, this is a point mass. No, suppose with respect to sun, Earth is a point mass, right? Because distance is very very large. So if I want to keep that both charges, this rigid charges, at a distance of 1 kilometer, 2 kilometers, so we can treat, okay, this is treat as a point charge. See, so what is limitation? We cannot apply. We cannot apply Coulomb's law for extended charge. We cannot apply Coulomb's law for extended charge, right? And one thing, see, this charge Q1 assume point and this also point charge. Both are present in its rest condition. Okay, we can apply this Coulomb's law. Both are, suppose one is moving, but one charge is in rest. Here also we can apply Coulomb's law. But both are moving. In this case, this is part of means dynamics. And in case of electrodynamics, we cannot use Coulomb's law, right? Because Coulomb's law is the part of electrostatics. See here. So if no need, if both charges are in rest condition, okay, we can apply Coulomb's law. One is moving, one is in rest, we can apply Coulomb's law. Both will move, no, we cannot apply Coulomb's law. Simply. Next. What is principle of superposition? See. Principle of superposition. First write definition, then I will explain. In a system of n charges, the net force on any one charge in a system of n charges, the net force on any one charge is the vector sum of the force due to all remaining charges on this particular charge. What is the meaning of this principle of superposition? See, suppose we have simply I want to ask one question, Q1 and here suppose Q2, both are suppose distance r, right? I am asking, tell me here force will exist or not. I am not asking force is attractive or repulsive, no. Just I am asking force here attractive or repulsive. It is another question. But tell me here force will exist or not. Yes, force will exist because here two charges present and due to that charges force will exist. Now my next question, which force? Repulsive force, because both have same sign. Okay. And next thing is, always this force and this also, and gravitational force also, it will lie on the line joining that given charge. So here at repulsive force, so here force will be look like this and here force will look like this. In case of attractive force, this type, right? Attractive, but always along this line join. Okay, here actually repulsive. Very good. This is called F12 and this is called F21 because force on 2 due to 1, force on 1 due to 2. Very good. Why here force will exist here? Force because due to 2 force will exist here and that force is repulsive. Here also why force will exist due to force on 2 due to 1. If not 1% now, no force present here. Understood? So just I am writing here Q1, right? See. So you can solve easily in case of two charges, but suppose we have another charge also Q3 and assume this distance R, this distance also R. Now I am asking one question all of you. Here on Q1, force will exist or not? Yes, it is here. On Q1, force will exist due to Q2 and Q3. If that will not present here, then here no forces present. Due to this Q2 and Q3, here force will exist. Okay, very good. So simply one by one, I want to solve. See Q2 here. Tell me this way force will be Q1 respect due to 2, and here also see. Now if you want to take system of Q1, Q3, this is your line joining. Am I correct? Line joining. So here force will attractive or repulsive? Attractive. So at Q1, I think this type of check force, and this force is called Q1 due to 3. Very good. Let's see R. What is meaning? Equilateral triangle. So this will be 60 degree. This will be also 60 degree. Correct. Now you know simply suppose we have a vector and suppose we have b vector 60 degree or any angle theta. Both are vector quantity, right? So just I want to calculate resultant of that vector quantity. So what is resultant? Under root means mod magnitude here. Resultant mod equals to under root a square plus b square plus 2ab cos theta. Check. Am I correct? Similarly here also same. Check here. This is a F12 and this is a F13, right? And this angle is 60 degree. So first tell me what is F13. You can tell sir this will be K Q1 Q3 by R square. And what is this? K Q1 Q2 by R square. So I want resultant. So resultant vector will be equals to under root F13 square plus F12 square plus 2 F13 F12 cos 60 degree. Right? If you will solve, then you will get the resultant of that given forces. Correct? So now I want to explain now what is the meaning of principle of superposition. See, actually here I have taken first question, I have taken 2 charges. Second question, I have taken 3 charges. Suppose infinite charges, infinite. See, in case of infinite, suppose here Q1 and Q2 and Q3, Q4, Q5, Q7, Q8, Q9, that's not Q10, Qn. Correct? Now suppose these distance R1, R2, and this distance suppose R13, this distance R15. Very means number of charges very large, right? R16, distance R18, right? Many. So I am asking one question. Tell me what is net force on charge N? Calculate and tell me.